Assalamu alaikum. This is Umair Ahmed, and I'll be presenting to you our linear algebra final presentation, which is basically on balancing chemical equations using linear algebra. So let me just take you to the slides. Assalamu alaikum. So this is basically our presentation on linear algebra applications, and we chose balancing chemical equations. So these are group members: Zuhair, Hassaan, Abdulrehman, Anfa, Saad Ahmed Khan, Taha, Shaheer Alam, Hassaan, Farooq, and then there's me. So let's move on to the main part of our presentation, which is why do we actually need to balance a chemical equation? Why does it need to be balanced? So the answer for this is that chemical equations need to be balanced in order to satisfy the law of conservation of matter, which is a phenomena in physics and chemistry, which states that in a closed system of matter, in a closed system, matter is neither created nor destroyed. So there are different techniques which exist for balancing chemical equations. Balancing chemical equations by chemists is typically done by first identifying the uncommon elements in a compound and then working your way towards basic elements such as hydrogen and oxygen. But there also exists a rather more efficient and systematic approach, which is by using linear algebra. This method really comes in handy when the number of elements we are dealing with increases. So let's see how that's done. So the basic methodology behind how do we balance a chemical equation using linear algebra is, firstly we put the elements in the matrix form. Uh, then we form an augmented matrix where we plug the matrix into a where we plug the chemical equation into the matrix. Then we solve it using Gaussian elimination and reduce it to echelon form or row echelon form as we require. So I'll go through a basic problem, uh, after which my peers, my team members will give a detailed example, a detailed overview of different problems we can face while balancing chemical equations using linear algebra. So this is just a basic problem where we have chemical equations such as C2H6, which has X number of moles, then O2, which has Y number of moles, then CO2, which has Z number of moles, and then H2O, which has T number of moles. So this equations needs to be balanced, and we need to know the correct values for X, Y, Z, and T, so that we get a balanced equation. So we do this by linear algebra. And how do we do this? So our first step will basically be to find the amount of each type of atom. So I've done that by writing it in parentheses. So 2x is the number of carbon, then 6x is the number of H. After that, 2y is the number of O. Then on the other side of the equals to, it's Z number of carbon, then 2Z number of O, then 2T number of H, and T number of O. So we can reduce this down further by equaling each coefficient to itself. Like for example, we have carbon here and here, so we'll equal both the coefficients of carbon to each other, which is 2x equals to Z. Then for T we will do the same, and then for oxygen we will also do the same. So here we have three equations. Then we move on to the next step. The next step is basically writing the equation we formed earlier into an augmented matrix form. These are equations, and I've just plugged it into the matrix, and I formed this matrix, which is an augmented matrix. In the next step, uh, we will basically simplify the given augmented matrix using row operations, and this is what we get after a certain amount of row operations. This is the matrix that we get, and from here we can observe that the column number 4, which basically represented the t variable, which we needed to find, is a free variable. So all the other variables we needed to find, such as x, y, and z, are forming in the form of t, and t is free. So let's see how we will deal with this free variable. So this is basically a final step as well, because we mostly have the 90% of our job is done, and we just need to figure out a suitable value for t, and we will have a balanced equation in our hands. So free variable, if we talk about the free variable t could be basically any real number we like. However, it is preferred that you use the t variable, which is the LCM of all the other values. For example, if I use a 6 here, I know that the LCM of these three other variables which I've got, 2 over 6, 7 over 6, and 2 over 3, the LCM of all these three is 6. So I've used 6. I plug 6 in place of t, and I get some equation which is some values, which is I get x equals to 2, then y equals to z, y equals to 7, and z equals to 4, and t equals to 6, which was there. So this is, I formed a balanced equation. So I think this is all for this basic example.
Hello, my name is Anfa Majid, and now we'll be looking at the first chemical equation, and we'll be using the array applications, echelon form matrix, to solve this and put this equation into a balanced form. So first of all, हम लोग के पास इधर कार्बन डाइऑक्साइड है, water है, that is gonna react and make oxygen, and C6H12O6. X1 जो होगा वो कार्बन डाइऑक्साइड के मोल्स होंगे, X2 जो होगा वो वाटर के मोल्स होंगे, X3 जो होगा वो ऑक्सीजन के मोल्स होंगे, एंड X4 जो होगा वो C6H12O6 के मोल्स होंगे. अच्छा, तो हम लोग के पास ये एक बैलेंस इक्वेशन को हम चाह रहे हैं हमारे पास आ जाए, तो वी विल बी ट्राइंग टू गेट के C जो लेफ्ट हैंड साइड पे C के मोल्स हो या मॉलिक्यूल्स हो, दैट शुड बी इक्वल टू C के मॉलिक्यूल्स ऑन द राइट हैंड साइड. लाइक इधर जो C6 है, इसके जो मोल्स होंगे दैट शुड बी इक्वल टू CO2 में जो C है, एंड सेम थिंग गोज विद ऑक्सीजन एंड हाइड्रोजन. So first of all, we will be putting these x1, x2, x3 and x4 in an equation. तो हम लोग ने जैसे कार्बन का हमने यहाँ पे लिखा हुआ है x1 is equal to 6 times x4. यहाँ पे कार्बन का मॉलिक्यूल 1 है एंड इधर कार्बन के मॉलिक्यूल 6 है. हमने दोनों साइड ऑफ द इक्वेशन से मोल इक्वल करने हैं. दैट मींस कि हम लोग के पास x1 शुड बी, जो जिसमें एक मॉलिक्यूल है, शुड बी इक्वल टू 6 टाइम्स, क्योंकि इसके 6 मॉलिक्यूल्स है, x4. ये हमारे पास कार्बन की हो गई इक्वेशन. देन वी हैव हाइड्रोजन. हाइड्रोजन में हमारे पास H2 है जो कि मोल्स है वाटर का. यहाँ से हमने H को एक्सट्रैक्ट कर रहे हैं, उसके दो मॉलिक्यूल्स हैं. देन वी हैव रिटन 2H2. देन राइट साइड ऑफ द इक्वेशन पे हमारे पास 12 मॉलिक्यूल्स हैं और हमारे पास X4 मोल्स है. तो हमने जब इनको इक्वेट कर रहे हैं तो दैट इज 2H2 इज इक्वल टू 12X4. सही, यहाँ पर हाइड्रोजन की इक्वेशन हो गई. यहाँ पे हम सिर्फ ये देख रहे हैं. अच्छा, X3 जो आया था, X3 हमारे पास आते हैं, सॉरी, ऑक्सीजन को जब हम इक्वेशन में कन्वर्ट कर रहे हैं, दैट इज हमारे पास कार्बन डाइऑक्साइड में भी ऑक्सीजन है, वाटर में भी ऑक्सीजन है, यहाँ पे ऑक्सीजन गैस है, एंड देन वी हैव इन दिस कंपाउंड वी आल्सो हैव ऑक्सीजन. सो हम लोग जब इसको इक्वेशन की फॉर्म में कन्वर्ट करें तो दैट इज यहाँ पे दो मॉलिक्यूल्स हैं, तो 2 times is x1. देन यहाँ पे हमारे पास एक मॉलिक्यूल है ऑक्सीजन का, दैट इज 1 into x2. हम इन दोनों को ऐड करेंगे, दैट शुड बी इक्वल टू 2 molecules x3 plus 6 molecules x4. That's why we are writing here 2 times of x1 plus x2 is equals to 2 times of x3 plus 6x4. ये हमारे पास ऑक्सीजन की इक्वेशन आ गई, हमारे पास हाइड्रोजन की इक्वेशन, देन हमारे पास कार्बन की इक्वेशन आ गई. सही है. अच्छा, इसको हमने फिर क्योंकि ये इक्वल होना है, देन वी हैव कन्वर्टेड दिस इनटू दिस, वी हैव इक्वेटेड, लाइक हमने इनको 0 से इक्वेट कर दिया. सही है. देन हमारा जो स्टेप 1 है वो ये होता है कि हमारे पास ये इक्वेशन होती है a into x is equal to b, where a is a coefficient matrix, x is a column matrix, and b is the equivalent that is also right now 0 के हमने निकालना होता है. तो हमारे पास ए जो कोफिशिएंट मैट्रिक्स होगा वो हम ये जो 3 इक्वेशन है इनको यूज करके हमने एक कोफिशिएंट मैट्रिक्स निकाला है. इनको हम मल्टीप्लाई कराएंगे x1, x2, x3, x4 से, जो कि हमारे पास मोल्स है इन द मेन इक्वेशन. सही है. एंड देन वी विल गेट द आंसर. अच्छा, इसके बाद स्टेप 2 एंड स्टेप 3 जो है वो आपको एक्सप्लेन करेंगे शहीर आलम.
So my name is Shaheer, and now I will explain you step 2 and step 3 for how to solve this equation. So first of all, as you know, this is a homogeneous system, so we don't have to write the augmented matrix for this. First, we will apply row operations so that we can convert this matrix into REF form. So first we will swap these two rows so that we can convert it into REF form, and after that we will apply the first row operation, that is R2 is equals to R2 minus 2R1. So first we will swap these two rows. So
हाँ स्वैप कर लो.
So after swapping the rows, we will apply the first row operation, that is R2 is equals to R2 minus 2 times R1. So for this we will copy the first row as it is, that is 1 0 0 and minus 6. Then row altered, and that would be 0 1 minus 2 and 6, and row 3 would be copied as it is, that is 0 2 0 and minus 12. After that we would apply the second row operation, that is R3 is equals to R3 minus 2 R2. For this we will copy row 1 and row 2 as it is, and after this the row 3 would be altered here. So row 3 would be altered like R3 minus 2 R2. Okay, so row 3 would be altered like it would be 0 0 4 and minus 24. So as you can see here, we have leading entries in row 1, row 2 and row 3, and the fourth row has no leading entry. So this would be called as our non-pivot column. And we have to assign a free variable for this column, that is we have to assign a free variable for x4. So for this we will first write all these equations now, that is x1 minus 6x4 is equals to 0, that will represent this row. Then we will write x2 minus 2x3 plus 6x4 for the second row, and 4x3 minus 24x4 for the third row. And now as you know that this is the non-pivot column, so a free variable would be assigned to this column. So we will suppose x4 is equals to t. So after this we will first of all, this would be equation 1, equation 2 and equation 3. First we will substitute the value of x4 in equation 3, that would be 4 times of x3 minus 24 times x4 is equals to 0. So 4x3 minus 24, we will replace x4 with t, is equals to 0, and 4x3 is equals to, now we will solve this, and x3 would be 6, and this is 24t, so x3 would be 60. So like after this we got the value of x3 and x4, we will solve equation 2. To solve equation 2 we will substitute the value of x4 and x3 into equation 2. So it would be x2 minus 2, the value of x3 is 60 minus 2 times 60 plus 6 times the value of x4 is t is equals to 0. So x, we will solve this and it would come out to be minus 12t plus 60 is equals to 0, and x2 is equals to 60. x2 would also be 60. Now we will lastly we will substitute these values into equation 1, and that would be x1 minus 6t is equals to 0, and x1 would also be 60. T is equals to 0, and x1 would also be 60. Now we got the values of x1, x2, x3 and x4 in terms of t. After this, Okay, so T is the limiting reactant. So we will choose a minimum value for T that could be 1. So if we assign 1 to T, then x3 would be 6, as x3 is 60, x2 would also be 6 and x1 would also be 6. So as you know, in this equation we have the unknowns x1 here, x2 here, x3 here and x4 here. So in place of x1 we'll write 6, in place of x2 we'll write 6, x3 would be 6 and x4 was 1. So we will write 1 here and that's how the equation would be balanced.
Here we have the equation of tin dioxide plus hydrogen, which forms tin and water. In this equation we have 3 elements, and to find the number of elements needed for this equation, we have to calculate the variable associated with each of the 3 elements. So from this equation we put a variable in front of each element. For tin, the equation becomes, since there's 1 tin here and 1 here, the equation becomes x1 equal to x3, which simplified becomes x1 minus x3 is equals to 0. For oxygen, we have 2 oxygen over here and 1 over here. So that forms 2x1 is equals to x4. Simplifying becomes 2x1 minus x4 is equals to 0. Now for hydrogen, we have the equation 2 hydrogen here and 2 over there. That forms 2x2 equals to 2x4. Forming to get 2x2 minus 2x4 is equals to 0. Now we have 3 equations for 3 elements. The 3 equations we will now simultaneously solve are x1 minus x3 is equals to 0. 2x1 minus x4 is equals to 0. 2x2 minus 2x4 is equals to 0. Now, because we have 3 elements and 3 equations, we can simultaneously solve the 3 equations using linear algebra to find the constants needed to create a balanced equation for this reaction. Also, since the results are always equal to 0 here, the system is always homogeneous. That means there will always be a solution for this set of equations. Now, Abdulrehman Ansari will solve these 3 equations using low echelon form.
Assalamu alaikum. My name is Abdulrehman Ansari and I will be solving these equations to get the balanced equation we needed. So I've gone ahead and made the matrix for these equations, for this column being x1, this column being x2, and this x3 and this x4. Now we are going to be turning this matrix into the row echelon form, bring it to the row echelon form. So for that, I will be multiplying row 1 and subtracting it from row 2. So now I get the first row as is. The second one I will be getting 0 over here, and then multiplying this by 2 and then subtracting it, so I'll be getting 2 and minus 1 and 0. And the third one I will be keeping it the same. So 0, 2, 0, minus 4. Now since this has a leading entry in this second column and this has a leading entry in the third column, I will be swapping these 2 rows. 1, 0, 1, minus 1, 0. This remains constant. 0, 2, 0, minus 4, 0. And then 0, 0, 2, minus 1. So this is my matrix I get in the echelon form. Now I will be solving for x1, x2 and x3. So for x1, over here, since there is no leading entry in the fourth column, I will be making this a free variable. Let's lower it over here. So from the third equation, I first get x4 as a free variable. I'm naming it s, and s is a real number. It can be any number it wants. We have in the third equation 2x3 minus x4 equals to 0. We substitute x4 as s, and then we get x3 as s by 2. Okay. From the second row, we get 2x2 minus 4x4 equals to 0. We substitute x4 as s again. 2x2 minus 4
s equals to 0, and then x2 we get as 4s by 2 or 2s. For x1 again, we go back to row 1, we get x1 minus x3 equals to 0. x3 we have already figured out as s by 2, so x1 minus s by 2 equals to 0, and then x1 we get as s by 2. Now, since we have all these equations, we have the values of x's, we get x1, x2, x3, and x4 as s by 2, we have 2s, we have s by 2, and then we have s. Now we can plug this into the original equation, which was x1 Sn O2 plus x2 goes into x3, it was Sn plus x4 H2O. Now we can plug these values in here and we can get S by 2 SnO2 plus 2S H2 S by 2 Sn plus SH2O. So over here, these S's depend on X4, which was our H2O. So whatever number of moles we get for H2O, we can we're going to get as many moles of the other ones, since H2O is a free variable and it will be the limiting reactant in this reaction. Thank you.
Another way to solve the same problem of balancing equations. So here we have this equation C3H8O2 is the reaction gives us carbon dioxide and water. So we are going to produce this in a matrix form in which C is the first row, H is the second row, and O is the third row. Now representing it like this, x1 will be the coefficient, C key value 3, H key value 8, and there is no O over here for x1, so we're going to put 0 here. For the second one, x2 coefficient, there's only O2 here, so we're going to put 2 in the place of O and then 0 above. And then the reactants, x3 coefficient, carbon is 1, oxygen is 2, and then there's no hydrogen, so 0, plus x4, H is 2, O is 1, and then no carbon. So we represented this in the matrix form, and now we're going to bring the reactants to the other side, the products to the side of the reactants. So the sign is going to change. 3, 8, now we're going to bring this into an augmented matrix. So removing the coefficients now, 3, 8, 0, 0, 0, 2, 1, 0, 2, and then 0, 2, 1. And now we're going to put up the signs as well for this row is minus, this one 2. And now my friend Zuhair is going to continue the decision.
Assalamualaikum everyone, Saima speaking here, and I will now explain the working of this augmented matrix to balance the following equation. Now, as you can see here, the for this to solve in row echelon form, the second row the first element of the second row must be 0. So for it to be 0, I will have to apply the echelon form rules, which is R2 equals to, now for this to be equal to 0, I have to multiply this number with a number such that it makes this number 0. So I will multiply by 3 upon 8. This 3 upon 8 will, when multiplied by 8 will give us 3, and 3 minus 3 will give us 0. So the first element will be 0 here. You can see. Now 3 upon 8 into 0 will give us 0, and 0 minus 0 will give us 0. Minus 1, 0. 3 upon 8 into 0 will give us 0, and R1 is this element which is minus 1. So minus 1 into minus is plus 1. And then we have minus 2 over here. Then we have 0, minus 2. Now minus 2 is a R2 value, so we'll multiply by 3 upon 8, which is minus 6 upon 8, and it's minus by R1, which is 0 over here, so it will be minus 6 upon 8. Now we can also do another thing over here. We can swap these two rows as well, because for this to be the row echelon form, the second row must have this element as must have this element as a non-zero value, and the third row must have this element as a non-zero value as well. And as you can see, the second row is fulfilling the third row's echelon form as well. So we can swap these two rows and write it like this. Now, as you can see, all the rows have their own pivot columns as well. As you can see, the first element is a non-zero value of the first row. This element is a non-zero value for the second row. So you can see that these three columns are the pivot columns, except for this one, because this does not have a non-zero value as this first. So this is our non-pivot column. Due to this, we will consider this column as a free variable as well. Since this column was for x4, so x4 is our free variable, which will be any variable we want. So we will make it t. So x4 is our t. Now we will write down the equations and use the value of x4 in these equations to get the values of x1, x2, and x3. So we have x3 minus, for the third column, for the third row, we have x3 minus 6 upon 8, x4 equals to 0, which then plugging the value of x4, you get this. And this can be simplified to 3 upon 4. Now we will write the second equation. Plug in the values of x3 and x4 here. This will become 5.2. Now we will write this equation. We will plug in the value of x3 here. Now, since we got the values of x1, x2, x3, and x4, we can now plug in these values. We will write this in the equation: x1 C3H8 plus x2 H2O, x3 C H CO2 plus H2O. See? Now we will plug in the values of x1, x2, and x3 and x4 here. since x4 was our limiting free variable, h2 becomes our limiting reactant as well. And depending upon the value of t, we can use any, depending on the value of t, we can balance this whole equation. So, thank you.
अस्सलामुअलैकुम, मेरा नाम मोहम्मद ताहा समजी है और मैं केमिकल इक्वेशंस को मैं बैलेंस करना सिखाऊंगा। तो ये हमारा इक्वेशन है, ये सोडियम फॉस्फेट प्लस बेरियम नाइट्राइड इक्वल्स टू बेरियम फॉस्फेट और सोडियम नाइट्राइड। तो हमने इनको बेसिकली इनके मोल्स इक्वल करने हैं। तो यहाँ पे सोडियम फॉस्फेट के हमारे x1 मोल्स हैं, x2 मोल्स बेरियम नाइट्राइड के हैं, x3 मोल्स बेरियम फॉस्फेट के हैं और x4 मोल्स NaNO3 के हैं। तो हमने यहाँ पे इक्वेशन को हमें वो बैलेंस करने के लिए सोडियम के मोल्स 3 मोल्स यहाँ पे हैं, x1 3x1 इक्वल्स टू सोडियम के मोल्स यहाँ पे 1 है, तो x4। x2 हमारा जो है बेरियम है, बेरियम के लिए यहाँ बेरियम 1 मोल है यहाँ पे इस साइड पे, और इस साइड पे हमारे बेरियम के 3 मोल हैं। नाइट्राइड के हमारे इस साइड 2 मोल्स हैं, नाइट्राइड के साइड 2 मोल्स हैं, और x4 और राइट साइड पे हमारे नाइट्राइड के हमारे 1 मोल है, और लेफ़्ट साइड पे फॉस्फेट का 1 मोल है, और राइट साइड पे 2x3 जो हमारे 2 मोल्स है राइट साइड पे। तो हम इसकी इक्वेशन बनाएंगे, 3x1 माइनस x4 वहाँ चला गया, x4 इक्वल्स टू 0, x3 वहाँ चला जाएगा, x2 माइनस 3x3 इक्वल्स टू 0। नाइट्राइड के लिए 2x2 माइनस x4, 2x2 माइनस x4 इक्वल्स टू 0, और फॉस्फेट के लिए x1 माइनस 2x3 इक्वल्स टू 0। तो यहाँ पे नाइट्राइड के मोल्स, ये x4 वहाँ चला गया, 2x2 माइनस x4 हो गया, 2x2 माइनस x4। यहाँ पे फॉस्फेट के लिए x1 माइनस 2x3 हो गया इक्वल्स टू 0। अब यहाँ पे हमने इसकी ऑगमेंटेड मैट्रिक्स बनाई है इक्वेशन 1, जिसमें x1 3 है, x2 0 है, x3 0 है, और x4 माइनस 1 है। और सिमिलरली इक्वेशन 2 के लिए x1 0 है, x2 1 है, x3 जो है माइनस 3 है, और x4 0 है। सिमिलरली अपने इक्वेशन 3 के लिए x1 0 है अपना, x2 2 है, x3 0 है, और x4 माइनस 1 है। और सिमिलरली अपने फोर्थ इक्वेशन के लिए x1 अपना 1 है, x2 0 है, x3 माइनस 2 है, और x4 0 है।
Assalamu alaikum, Saima Khan here, and I will be continuing from where Taha left. So this is the equation which we have. We have used x1, x2, x3, and x4 to represent the moles of the complete of the balanced equation. So this is the matrix which Taha created before me, and now we will be solving this matrix. We will be first converting this matrix into a row echelon form and then solving it. So in order to save time, I have already applied all the necessary row operations which are necessary to convert this into a echelon form. And now this is the converted echelon form matrix, and now we will be solving this matrix to get x1, x2, x3, and x4. So from equation 4, we can clearly see that x4 is a free variable, so we will represent it by t. From equation 3, we get x6, x3 is equals to x4, so x3 will become t over 6. From equation 2, we get x2 is equals to 3x3, so x2 will become 3 over 2, and 3x1 is equals to x4 from equation 1, so x1 will become 3 upon 3. So now if we choose any arbitrary value for t, so if t equals to 6, we will get x1 will become 2, x2 will become 3, x3 becomes 1, and x1 becomes 6. So now we will be writing the entire equation once again to confirm that the equation is indeed balanced. Now let's say x1 by the default values that we have found. So x1 is 2, so that means the PO4 plus 3 and 3 taken twice, and then BA3 PO4 taken twice. So as you can see over here, all of the moles of each individual element are balanced on the left hand side and the right hand side. Sodium is 6 over here, and over here it's 2 multiplied by 3, 6. And same goes for all the rest of the elements, which we can easily verify. So this is how we use linear algebra to balance chemical equations.